we have seen that we are now putting these apparatus the way they are supposed to be placed when they are carrying the chemicals. I want to show you how to arrange the apparatus in the test tube rack. This one is being placed here, and the other one is being placed here, as you can see. And remember, when these apparatus are carrying, when you have washed them or cleaned them, you put them like this, you put them like that, so that the water can drain out very quickly. The water can drain out very quickly. The water can drain out very quickly. You can even put this one there, and among others, you can even overlap, as you can see. Then you place it out, you place here. I was just showing you on how to place the apparatus on the test tube rack. We have seen that these apparatus are made of glass to prevent rusting, for easy cleaning, because the chemicals will not stick on the sides of the apparatus. And then number 3, for easy, because this apparatus won't rust. There will be no rusting there, even if you leave them for 100 years. So these apparatus are very delicate. These apparatus are very delicate, as you can see. I'm placing them slowly and carefully, slowly and carefully to prevent breakages. There's another thing. Apart from test tubes, the boiling tubes, we have this apparatus here. So this apparatus here, we call it graduated 100 milliliters measuring cylinder. So this one is measuring cylinder. This one is measuring cylinder. As you can see, it has 100 milliliters. It runs to 100 milliliters, as you can see. 100 milliliters. Another one. We are very fast because of time. We are very fast because of time. We are very fast because of time. You don't want to run out of time. Yes, if there's this apparatus here, I want us to learn this apparatus, this one. These are called pipette. These are called pipette. You can see them. It is 25 milliliters. It measures accurate solution. It measures accurate solution. You can see a mark there, up here. You can see a mark up here. So this one is where the solution should be reach, especially when you are doing the practicals of titration. Burettes and the pipettes go hand in hand. You can't use pipette alone unless when you are measuring accurate volumes. Let's get another apparatus. So we have learned burette, pipettes. Burettes are up there. So let's learn another. Today's Sunday of learning apparatus alone. These are called beakers. They are used to hold the chemicals. They are also used to hold reactions when they are taking place. This is the smallest one. It has got 100 ml. We have 50 ml apparatus, beakers. Kuna 500 milliliters and 1000 milliliters. That's 1 liter. Another apparatus that we are going to learn is this one. This one is called litmus paper. This one are called litmus paper, but this one is blue. As you can see, the color is blue. Therefore, this one is blue litmus paper. This blue litmus paper. So the color of this one changes according to the nature of the solution. If the gas coming out from the solution is acidic, this blue litmus paper will change to red. And if this is red, like this, you can see me removing this one. So if it is red, so this one indicates that the litmus paper there is red in color. If it is red, now it changes to blue to indicate that the gas is coming out is basic. So if the gas is basic, the red litmus paper changes to blue, and if the blue litmus paper remains to be blue. And if the solution produces gas that is acidic, the blue litmus paper changes to red, and the red litmus paper remains red. This one is called a pH universal indicator chart. It's called universal full range indicator chart, running from number 1 to number 14. Number 1 is highly acidic, and number 14 is highly basic. Number 14 is highly basic. Then number 7, as you can see, that one is neutral. Number 7 is neutral. That's where water and milk belongs. Then hydrochloric acid, nitric acid, sulfuric acid belongs in pH 1. And the way you move towards the right, as you can see, the strength of acidic in a solution and decreases as you move across the pH indicator chart. And the way you move towards the far end, that's now 12, 14 uko, that's now the strength of basic increases. So we have to learn something else apart from those things we have seen there. Let's try to learn something else. So this one is Ngasinja. It is also made of gases and glass, not gases but glasses. It is made of glasses, you can see. So this one is also made up of glasses, and it is heavy so that it can sink in the water when inadvertent to collect or to pick the gas. And it is also used for reactions. You can put some reactions in and there, and also to hold some solutions that you feel to hold. Another thing that we are going to learn is magnet. Magnet is another apparatus that you can use. So this magnet you see here, it has got north and south pole. There are two. They are placed in pairs, and in between them there is a plastic separator or boundary, so that now when we place or we store these magnets will not be interfered. There will be no collision, there will be no breakages, among others. So allow me to place them. This one is cooking fat. You can see this one is cooking fat, and we use them in laboratory, especially when we are learning the reaction, not reaction, but when we are doing apparatus, when we are doing what? When we are experimenting on melting of substances in the laboratory. So that's a practical there in grade 8. That's now the physical state of matter. This one is solid, but when heat is increased, it will no longer remain solid. It will change to gas, I don't change to liquid, and that liquid, when the temperature is reduced, changes back again to solid. So this one is for experimenting melting of solid in laboratory. Remain notified. There's another thing here I want us to check, learn today, in this day of learning practicals. This one is glass rod. Check the glass rod. This is modern glass rods that we should be using for stirring and mixing the chemicals. Stirring and mixing chemicals. Yes. This one is called a clamp. This one is called a clamp for holding the pipettes, the burettes, for holding pipettes and burettes when the apparatus are this one is called test tube rack. Test tube rack. This one is called test tube rack. Let's see how it works. This one is called test tube rack. So you hold it. This way. You hold it this way. Then you squeeze or you press this one so that it can hold the apparatus tightly. You can now, when you are burning, you can just hold it over the flame. You can hold it over the flame, and always remember that a luminous flame is always invisible. I know you are not seeing the flame, but the flame is very hot. The flame is very hot. It's trying to demonstrate on how you should be holding the apparatus when you are heating. So we have said this one is a test tube holder. It is made up of wooden. The handle is made up of wooden parts so that the heat cannot injure or hurt the person holding the apparatus. Do not hold the apparatus when you are burning with your hands. This one is called spring balance. This one is called spring balance. You can see it has a spring inside. It has a spring inside. You can see from this point. This one is for measuring weight of objects in laboratory. Weight in newtons. Remember, this one is written in newtons. It is used to measure or to weigh small objects that are found in laboratory for demonstration. This one is dropper. It is used for dropping drops in the test tube or on boiling tubes or in the beakers wisely. This one is thermometer. Laboratory thermometer. There are another one known as clinical thermometer. So this one is a laboratory thermometer. You can see the color. This one is, I think this one is alcohol thermometer. This is alcohol thermometer. Thermometer is used in laboratory for measuring temperature of solutions. So it is being stored in its own way, like this. You can see the way I've started storing it. Then you close the other end like that. Check.